Hi, folks. Welcome to the first video for your review for exam 2. And in this video, we're going to take a look at some of the trig review, okay? And so in particular, this should correspond with sections 8.1 through 8.4 in your textbook, okay? All right. So we're going to do a bunch of examples here, see how it goes, but the name of the game is really thinking strategy and thinking about, do I know what rules to use when? Okay. And am I taking a derivative or am I taking an integral? All right. So let's get started. All right. Example number 1. Let's find the derivative of e to the 2x sine x. Okay. So as you start questions, I really encourage you to think strategy first. Like, what rules are you going to use instead of just like starting to write? Okay. So when I look at this problem, I notice first of all that I'm taking a derivative. And we know quite a few rules for derivatives, right? We know our power rule, we know our product rule, our quotient rule, chain rule, all these rules. And if we think about which one might be applicable here, I can really imagine that this is like e to the 2x times sine x. And so when I see that times, I am immediately thinking I want to use my product rule, okay? And even though product rule was something that we technically learned in Math 121 or the class before this, it is still a structure that we use kind of over and over again for these problems. So let's set up our product rule, okay? So our product rule, we need a u, that's like the first function, and then a v, which is our second function. And then we have to find our derivative of u as well as our derivative of v, okay? Now to find the derivative of e to the 2x, I am actually going to need to use chain rule. And the reason I'm going to need to use chain rule is because my power for my x is, or for my e is not just x, all right? So we got to do derivative of the outside, which is e to the 2x, times derivative of that power, derivative of 2x is 2. And I'm going to go ahead and rewrite this. I think it usually is written with the constant in the front, so 2e to the 2x. Okay? All right, now we've got our v is sine x, our derivative of sine x, that's what we learned in 8.3 is cosine x. All right, now let's plug this all into our product rule. Okay, so our product rule is u dv plus v du. All right, so let's plug in everything we have and see what we get. We've got u times dv, excellent, plus v times du. Okay. This is absolutely fine. You don't need to simplify it anymore. But if you wanted to, you could say, oh, I've got an e to the 2x here and an e to the 2x here. You could factor that out. All right, we get e to the 2x, and what's left? We've got cosine x plus 2 sine x. This would also be an acceptable answer, okay? But you lose no points for leaving it like this. In fact, by knowing you need to do the product rule and then your chain rule to find your du, you're really showing me most of the things that I'm looking for, okay? All right, let's take a look at another example. Okay, so let's take an integral of e to the negative sine x times negative cosine x dx. All right, so first question was asking us to find a derivative, and the second question is now asking us to find an integral, right? And so I'm kind of bouncing back and forth on purpose. I want us to have that flexibility in our brains, like, are we taking a derivative or are we taking an integral? All right. Well, if we think about what we know with integrals, we've learned a lot of different techniques, but in particular, the easiest one to start with is U sub. Okay. And so when we're thinking about U substitution, it's really nice to think about, do I see a function and at least part of its derivative somewhere? Okay. And so let's take a look at this power over here. U equals negative sine x. It would be really nice if that was just a u up there because I know the integral of e to the u is e to the u. So let's try that as our u. And we take a derivative and we get, let's see, the derivative of sine is cosine. So the derivative of negative sine is negative cosine. Oh, well, that's super perfect because negative cosine x dx, I can just replace with du. Very nice. Okay, so if I rewrite this, I end up with the integral of e to the u du. All right, look at how nicely this cleaned up for us. One small u substitution, bam, integral of e to the u, we can totally do that, okay? This is the strategy I'm really looking for us to do on these exams. Integration by parts, all that other stuff we learned, great. But before we try those, it would be a really good idea to just try U substitution and see if it works. Okay. Now we know the integral of e to the u is just e to the u plus c. And our last step, we want to go ahead and put back in our u. So we'll get e to the negative sine x plus c as our integral of that original question. Okay, so hopefully that was a good review of like what a derivative is and what an integral is. Let's try a couple more. Oops. Okay. So this time I want us to say for the function f of x equals cosine of 6x, I want us to find f prime of negative 11 pi over 24. Okay, so if we think about what that means in symbols, I want to find the derivative of this function. And after I find the derivative, I want to plug in negative 11 pi over 24, right? Okay, so let's take our derivative. And let's see what we get. So f prime of x equals, okay, derivative of cosine is negative sine of 6x, but because 6x is not just x, this means I need my good friend chain rule. So I need to multiply by the derivative of 6x, which is just 6, and it probably would be really nice to clean this up as negative 6 sine of 6x. Okay, that's my derivative. Now I just need to plug in that point that I'm interested in, negative 11 pi over 24. Okay, so f prime of negative 11 pi over 24 is negative 6 sine of, I'm going to write the 6 as 6 over 1. Okay, so 6 over 1 times negative 11 pi over 24. All right, now let's do a little bit of simplifying, see what happens here. When I take 6 and 24 and I divide them, I get 1 and 4. And so what I really have here is negative 6 sine of negative 11 pi over 4. Okay. Now, when we find 11 pi over 4 on our unit circle, so I'm going to draw a real quick unit circle, but we've got our pi over 4s right here. Okay, so this is 0. If I want a negative 11 pi over 4, I need to count in the opposite direction, okay? So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5, 6, 7, negative 8 pi over 4, negative 9 pi over 4, negative 10 pi over 4, negative 11 pi over 4. So this is the angle that I'm going to find the y value of because sine is the y value. Okay. Now, when I go ahead and find that y value, I get negative root 2 over 2. And this, the 6 and the 2 reduce to a 3 and a 1, and I end up with a positive 3 root 2 because I have a negative times a negative, which gives me a positive. Okay? So I think this is a really good question, kind of shows you like step by step how to find the derivative, how to plug in the point that you're interested in, and how to use your unit circle to find that value. All right, let's take a look now at another integral question. Okay, so example 4. I'm going to take the integral of 11 cosine x over sine x dx. Right? Now, again, this looks kind of complicated, but before we go jumping to all those other rules that we learned, like integration by parts and partial fraction decomposition, let's try use of. Okay. Now, let's let u equal sine x. Then our derivative is cosine x dx. And that's really nice because this cosine x dx, I can just replace with du. And so that gives me the integral of 11 over u du. And we know that the integral of 1 over u is just our natural log. So we get 11 natural log of the absolute value of u plus c. And our last step, everywhere we see a u, we got to put back in our sine x. So we get 11 natural log of absolute value of sine x plus c. Okay. So hopefully these 4 questions were a good warm up to our brains. Let's do one last one for this video, and we'll talk about how we might apply these in a scenario. All right, so example 5. Now we got a word problem here. I'm not going to write out the whole word problem, but I will give us the function that we're interested in, okay? So we're looking at a profit curve, all right? Our profit is given by the following function, 3 minus 3 cosine of pi t over 3, and t is between 0 and 52. Okay, so we've got some kind of profit function here. Let's practice finding a derivative, like what's p prime of t, okay? So let's call this part A, we'll find p prime of t. All right, well, that means I gotta take a derivative of this function, okay? This is actually gonna be pretty similar to this example 3 here, where we like found a derivative of a trig function. And maybe I'll want us to plug in a value. I don't know, but like this part shows us how we can plug in that value, right? Okay, so let's take this derivative. Derivative of 3 is 0. So we've got 0 minus 3. Okay, looks like I'm going to need some chain rule over here because I have cosine of something like pi t over 3. And that cosine's not just of t. All right, so the derivative of the outer function, derivative of cosine, is negative sine. And I like to put a parentheses here because I don't want to think that I'm actually doing like minus sine, right? It's actually times a negative sign. So derivative of the outer function times the derivative of pi t over 3, which is just pi over 3. Okay. Now this looks kind of gross, but let's clean it up. Let's see what we get. P prime of t equals, all right, negative times negative is going to be a positive, and then 3 times pi over 3. Let's see. So 3 times pi over 3 and sine of pi t over 3. Then I know that 3 and 3 reduce to 1, so I don't have to write them both, and I just get pi sine of pi t over 3. Okay? So if I wanted you to plug in a value for t after you've got your derivative, everywhere you see a t, you would just plug in whatever value there is there. Okay? All right, now let's imagine though that we were looking for an integral of p of t. All right, let's see what that might look like. We've got the integral of 3 minus 3 cosine of pi t over 3 dt. All right, so same function, but just in part A, I'm finding my derivative, and in part B, I'm finding my integral. Okay? All right, so our integral rule is a little bit different, right? 3, this first 3, it doesn't go to 0 because I'm not taking a derivative. But what did I take a derivative of to end up with 3? It was 3t. Okay? All right, minus 3. Oh, let's go backwards now. Derivative, or sorry, the integral of cosine is sine of pi t over 3. But this is a classic case for u sub. We're going to let u equal pi t over 3. That means our du is pi over 3 dt. But to get the dt by itself, I have to divide that pi over 3 to the other side. Okay? So let me take an extra step to write this. Du divided by pi over 3 equals dt. And one of the things I really want us to remember is when we're dividing by a fraction, it's the same as multiplying by the reciprocal. So in other words, I could say dt is equal to 3 over pi du. Okay? So when I integrate, there's an extra 3 over pi that I have to multiply that came from my u sub. All right, let's clean this up a little bit. We get 3t minus 9 over pi sine of pi t over 3. And this would be my integral for the very same function. Okay? This might not be a bad way for you to practice. Take a function for trig, practice taking the derivative, and then also practice taking the integral so you can kind of see what both directions look like. Okay? All right, so I'm going to stop this video here. In the other video, we will review all the things from chapter 7. So I'll see you there.